Let's talk about the mean value theorem. Now, the mean value theorem is a generalization of Rolle's theorem, which we had talked about in the previous video. Okay? And just like Rolle's theorem, the mean value theorem has a couple of conditions. So it has one fewer condition than Rolle's theorem. So the first condition is that f needs to be continuous on the closed interval from a to b. Okay. The second condition we have is that f is differentiable on the open interval ab. Okay. And these are both conditions. So these are conditions. Now, if both of those conditions are satisfied, then we have the following conclusion. Then there exists a C in the open interval AB such that f prime of C is equal to f of B minus f of A all divided by B minus A. Let's take a look at the left-hand side of this equation we just wrote. If you look carefully at what this left-hand side is saying, this left-hand side is basically the slope of the secant line connecting the endpoints. Okay. So when we look at the conclusion of this theorem, remember this last part here is the conclusion. What we can see is that this is an existence theorem. If these two conditions are satisfied, there exists some point. And what does this theorem say? It says there's some point that has the same slope, the same derivative as the slope of the secant line. So taking a look at our picture on the right over here, you can see that we have two endpoints, A and B. And our curve is here in blue. Now, if I were to connect the two endpoints of the curve from A to B, that's going to give me this dotted slope over here. And what the mean value theorem says is it says there's at least one point. In this picture, there's actually 2 points that have a tangent line that has the same slope as the slope of the secant line. Okay, so I think this picture does a good job of illustrating this theorem. Why don't we look at an example? Let's take a look at example 2. Okay, so in example 2, it says we have this square root function, f of x, and we're looking at this interval from 0 to 16. And we want to show that f satisfies the hypotheses or the conditions of the mean value theorem. And then, therefore, it shows that there exists at least one value, C, inside the open interval from 0 to 16, so that the derivative at this point is equal to the slope of the line connecting the two endpoints. The endpoints being 0 and f of 0, and 16 and f of 16. Okay. Then lastly, we want to find these values guaranteed by the mean value theorem. So let's take a look at this. The first thing we could say is that f is continuous on really the interval from 0 to positive infinity, because that's the domain of the square root function, right? So if it's continuous from 0 all the way to infinity, then this means f is continuous from 0 to 16. Okay, so we know what the square root function looks like. We know it's continuous on its domain, and in particular, it's continuous from 0 to 16. Next, I want to show it's differentiable. F is differentiable. The easiest way to show something is differentiable is to calculate the derivative. So I'm going to have, I can't say implies, let me say since the derivative f prime of x is going to be equal to 1/2 x to the negative 1/2, right? So this derivative exists on the open interval from 0 to 16. Of course, this derivative does not exist at 0 because when you plug a 0 into the derivative, you'll have a 0 in the denominator. So I need to put an open interval over here. Regardless, both conditions are satisfied. So the conclusion of Rolle's theorem says the following. So we're going to put 3 circles in a triangle. That means therefore. Therefore, this backwards capital E means there exists. So there exists a C in the open interval from 0 to 16 such that, usually we use ST to abbreviate, such that f prime of C is going to be equal to f of 16 minus f of 0 all divided by 16 minus 0. Okay? So let me evaluate the numerator. The square root of 16 is going to be 4. The square root of 0 is going to be 0. And then 16 minus 0 is just 16. So in the end, we're going to get 16 over 4. That's the same thing as 1 over 4. So there's some point that has a derivative equal to 1/4. All right. So now we want to find all the points that satisfy this particular instance of the mean value theorem. So what we're going to do is we are going to basically set f prime of C equal to 1 over 4, and we're going to solve for C. Okay, so what does f prime of C look like? That looks like 1 over 2 times the square root of C. That's the first derivative evaluated at C. We're going to set that equal to 1/4. Okay, so using algebra, I can multiply both sides by 4 and both sides by 2 rad C. And when I do that, I'm going to get 4 is equal to 2 rad C, like this. I can divide both sides by 2. Dividing both sides by 2 gives me 2 is equal to the square root of C. And when I square both sides, that's going to give me C is equal to 4. Okay, so now we've found the point that has the same slope as the slope of the secant line connecting the two endpoints of our curve on the interval from 0 to 16. I am going to highlight this final answer, and we will look at more examples in class together. Take care, everyone.